Hello, Ma'am Aubrey here, and welcome to the discussion on the Earth and the solar system. We are still in the pursuit of this learning objective, describe the characteristics of Earth that are necessary to support life. And we are going closer in achieving this learning objective now that we will be discussing the formation of the solar system and of the Earth. Okay, so just a quick review. In the previous lectures, we have discussed the Big Bang Theory, explaining the formation of the universe. And if we are talking about the universe, that's all of space and time, including matter and energy. So everything that exists comprise the universe. So when you think about the universe, it's not just outside of Earth, it also includes us. So all matter or all energy includes the universe. Okay, so you may have seen this image before. This is an artistic representation of our solar system. So you have your sun in the middle of our solar system. Okay, the first planet on closest to the sun, Mercury, followed by Venus, Earth, then Mars. Then we have your asteroid belt. We have Ceres here, which is a dwarf planet, followed by the Jupiter, Saturn, Uranus, Neptune. We have your dwarf planet Pluto, Makemake, another dwarf planet, and also Eris, located near the Kuiper belt. Okay, so we have, when we're talking about the solar system, we have certain parts. This part right here is called the inner solar system, and that's where your terrestrial planets are located. So that includes us. Planets which are dense and it's pretty much made up of rock and soil. So this is where we are at. And then we have your Jovian planets or the gas giants. So even if they are so large, most of them are just made up of gas and probably a small percentage of soil and rock in the middle. Okay, so how did this arrangement come to being? We have to discuss the formation of the universe because Earth is not isolated. Earth is definitely affected by our neighbors. So the sun gives us warmth, the interaction with the moon controls our tides. So definitely we have to discuss the rest of the solar system in order to understand Earth further. Okay, so that leads us to this question. How was our solar system formed? So the formation of the solar system is explained by an elegant theory called the solar nebula theory, or just the nebula theory. It is also called the modern Laplacian theory because this is an improvement of the earlier Laplacian theory proposed during the late 1700s. Okay, so as you can see here, this is the modern accepted theory on the origin of the solar system and the other solar system as well. So this is an explanation for all solar systems. Okay, so this is a combination of the work of the different scientists. The original Laplacian model had a problem when it comes to the angular momentum. And if you're familiar, angular momentum is the way certain objects spin. According to the Laplacian model, the original one, our planet should be spinning faster, but that's not what is observed by our astronomers. So it was debunked. But later on, due to the several contributions of scientists, we introduced a drag. So it's like a slowing down of the angular momentum computation because we have to include in our computation dust particles and the other objects in our solar system. So the meteors, the asteroid belts, and so on. And that would actually slow down the spinning of our solar system, thus leading to the accepted nebula theory. Okay, so this is also further supported by the observation of younger solar systems. So we'll look at that later. And then pictures with the observation of infrared radiations in other stars. Okay, So to further explain the solar nebula theory, let's discuss what's a nebula. So you may already know that a nebula is a giant cloud of dust and gas in space. So in plural, this is also known as a nebulae. And usually a nebula is a product of a supernova. So the remnants of a former star. Right. So, what happened is you have this nebula, okay, just a floating gas cloud in space. But due to certain events, perhaps due to a passing star or a supernova in a nearby space, it caused the gravitational collapse here in the middle of the cloud or the nebula. And because there was a collapse, just to maintain the matter within the nebula, it starts to spin on itself. So from this collapse in the middle, the pockets of dust and gas gather in the middle. Okay, so if you can imagine, this area begins to collapse, and due to that collapse in the middle, the whole nebula starts to spin. And as objects or several objects are spinning in one area, the denser materials will be aggregated in the middle, while the lighter materials will be aggregated here on the side. Okay, so because there is so much spinning here in the middle, heat and pressure start to build up, and it would result to the formation of a star, and that's what we refer to as our sun today. Then the materials that is not included in the sun, the formation of the sun, will be remained here, will aggregate here in a entity, not really an entity, like a formation called an accretion disk. So this accretion disk comprises of whatever is left from the spinning nebula. Okay, so the material here, the heavier materials form your sun, and then the lighter materials would form your accretion disk. And that would later, since the whole thing is spinning and they're bumping into each other, the particles will later gravitate towards one another and form larger bodies. So from being small meteors and just rocks spinning around in space, it would compress and gravitate towards another and form your planets. Okay, so this is a video which is showing the creation of the solar system animation. So just to give you an idea of how it all occurred. Okay, so just 48 minutes. So this is a nebula, and because of the collapse in the middle, the star started to form, and the spinning will still continue. And due to the spinning, the particles would coalesce or combine. Okay, there. So that's the formal formation of the star. Okay, and then here, whatever material is left that is not included in the formation of the sun will become the material that will form the planets. Looks cool, right? Yeah, so that's your animation of the solar nebula theory. Okay, so next slide. Okay. Alright, so how do we know that the solar nebula theory is true? Well, one evidence of that is with the observation of the other younger solar system. So this is an image taken by the Hubble Space Telescope, and this is an image of a young solar system called Beta Pictoris. Okay, so here in the middle, you will find a star, but if you can see, there's an occulting mask. So what they did was like put a filter on the star itself because it's too bright. You can't really observe anything. So they put a filter so that they can observe what is around that star. And what they can see is here two formations of accretion disks. So we have here your primary disks, which contains your gas and dust particles that are still spinning around in space, and then you have your secondary disk right here. So the secondary disk is much fainter than the primary disk because they can already observe that in the secondary disk there is already a protoplanet spinning around the young star. Okay. Okay, so that led to the formation of the solar system that we know today.